Everybody. That is a classic tune from from probably the 20s of your parents. So, hope you enjoyed that. Are we audio okay? And
Yep.
audio on you is okay. Do you like the tune?
Funky.
It is. Oingo Boingo. Oingo Boingo. Stay. Great tune. Obscure but great band. Okay. Let's do the thing. Do we have any housekeeping? Any nagging, whatever? I got housekeeping. Everybody got to get on the stick. Not everybody. There's probably like 3 of you. No, there's a percentage of you that are on the game, keeping track. We're on module 8, right? We're wrapping up module 8. So yeah, I said this at the beginning, and I've said it repeatedly at the risk of, at the risk of oversaying it. But you just can't let yourself fall behind because there's, conceptually, objectively, no deadline but the end of the semester. You know what I mean? I think it's illusory, and we have been debating whether we need to build in more deadline-ishness. The problem is it'll help some of you to, feel motivated by that, and others it'll actually hurt you, and so I'm not sure. And you definitely have to acquire the skill, Well, right, yeah. So, Jay, the idea would be moving fast, not too fast, but keeping up, and then not bombing. Yeah, that's key. You gotta, you know what I mean? It's spending the time to stay up that's really, kind of at issue. And then Caleb. So Caleb, you said LC3 has been real tricky. Do you mean the simulator or the architecture or the machine language or the assembly language? Can you clarify, Caleb? Yeah. So Jay, that's the language. Okay, I think in Caleb more the machine language or the assembly language that we've been working on. And Jay, not understanding machine language at all. I suspect that's not true. I suspect that you don't, that you do understand it at some level, but not as well as you want to. So I'm going to just go bold and say that you understand something. I know you've been here, but the key there is jump on with me. See, that's a separate issue. So jump on with me, jump on with the TAs. You know what I mean? And if we're not, if our hours, we're still shorthanded. We're still trying to replace Talmadge. But you can set up some schedule, some times with us, especially down the stretch. Yeah. Okay. Any other kind of housekeeping stuff? But we are available. You can hit us individually. And yeah, David had mentioned on the questions, some help with LC3 after class. And by the way, we could even do, we could either just keep this recording going, or we could do at some time, like an LC3 help section, just another focused time. I mean, I've done it in class, so I don't want to burn more time in class on it, but you know what I mean? We can potentially do like a help section or something. All right, let me see. So yeah, Mike had said you don't need to program in binary. That's sort of like true, not true, depending on if you're in assembly language, you don't need to. If you're in machine language, you can do assembly language and then do some conversion, but you do need to be able to look at it and understand it and operate kind of natively. And you know what I mean? So I think there is a good exercise, during the machine language portion of being able to drop the binary in and have that work. So David, you just said, when you paste your binary in, it does totally different commands than what you think you're telling it to do. Let's figure that out. We'll jump on it. We can either do that as kind of a continuation, or we can do that of class, or just as a separate help section. However you want to do it, whatever's going to be the most help for you guys would be just great for me. Yeah. Let me see. Ison asked, would you recommend focusing more on the slides of the book? I would focus first and foremost on the slides. The book is, supplemental and good. And there are situations where I think the book gets a little confusing. That's true. So what I would do is I would probably focus on the slides and the lectures. Since they're on YouTube, you can get to them, focus there. But then if you want to look at the book to kind of supplement, my main problem with the book is there are situations where, and this is always a problem, when you know a material really, really well, you have the curse of knowledge. And when you have the curse of knowledge, it means that you don't understand what other people don't know. And it's hard, right?
I feel like the book, it kind of like, not oversimplifies, but simplifies what you're trying to understand, but it really complicates things more than they actually are.
At
Because the
times.
questions the questions are like really easy, and you're like, okay. And then when you get when you find out the answer to them, or you like get help from a TA, you're like, oh, that was the answer. Oh, the book like said things that were like way more complicated than what I wanted originally.
Yeah. No, and I think that is true. I think that's true
That's why I
certainly
asked.
some of the time. Yeah. For example, when we're trying to do number systems, right, and the book uses polynomials to help explain number systems, well, that has a certain elegance to it. But the problem is that I think polynomials is a more advanced concept than
Right.
base.
Yeah.
And so you're using a more advanced concept to try to explain a simpler one, which if you understood the advanced one, you probably already understand the simpler
Right.
one.
Yeah.
That's the risk. That happens from time to time. The other thing that happens sometimes that I've noticed in the book is that the authors will occasionally say things which are true, but I mean, they typically, almost universally, say things that are true. But if you didn't know what it was, you wouldn't know by reading it what it was. You know what I mean? You can say
Oh
things
yeah.
that are true.
I've noticed that too. Yeah,
Right?
it makes it way
So you
more
feel they
complicated.
don't explain it very
Yeah.
well?
That's the high level view. But the way in which they don't explain it well is
They kind of like
by
assume that you already know what it
it's
is. Is
almost
that?
like an assumption. Yeah.
Yeah.
Sometimes it's
Yeah.
almost
I
like an
know that.
assumption.
Yeah. That's what I notice as well. Yeah.
Yeah, and the form that it takes is when you say something, when you say something that makes sense to somebody who already it's the black pearl. It's the black pearl approach, right? You have to know where it is, right, before you can find it, or whatever. How's that go, right? But it's like if I already know what it is, then I look at it and it makes sense and it helps me. But if I didn't know what it was, the words themselves didn't help me understand what it was. And that's the curse of knowledge. That I think is the struggle. And that's, of course, why we do the lecture thing, you know what I mean, is trying to backfill that, you know what I mean? And that's why I post it as well, so you can watch it as many times as you want, to try to get that. Because otherwise you're in a moment, you're trying to take notes, it goes by, you know. So, and so Jay, let's definitely go offline, grab some time. I can do it with you, or Zach or Vlad, depending upon timing and schedule, and even your preference. What is? Let me see. I'm just looking at the thing that Mike posted. Looks like something posted.
It's pretty helpful. It's like a uniform like map for everything. It shows
Okay.
all the key ideas of the LC3, the C to LC3 assembly language. I was
Okay.
just
Yeah,
looking at it, actually.
it basically shows on the left how you do it in C code, which is very minimalistic, and then on the right it shows how that converts to LC3, like
Yeah. Let me throw it
assembly.
up here.
So that way you can see, hey, this is how variables are initialized, or hey, this is how you kind of like do a general control flow, or because
Right.
that's, I mean, that I've been using this kind of stuff for learning it, and I found it really helpful for me
Okay.
at least. So if
Yeah.
somebody else can find help with it.
No, that's great. That's great, man. So, and in fact, so this is, I don't know this individual, Fritz Seeker, at Colorado State, but like to thank, if Fritz is a professor, I don't know, again, we can track him down and thank him. I mean, this is wonderful to have the resource out there. And for some of you maybe looking at that, this kind of gives you the, like, oh, here's what it would look like in C, and then here's what it would look like, that same idea translated. So if that's useful, right? Some of you might look at that and go, that's even more confusing. And others might be, no, this is exactly the kind of translation key that helps me. It's going to be personal, right? As to what's going to help most. But yeah, the link on that, Mike, thank you for posting the link, which is in the chat. In fact, I actually considered and am still considering doing a segment of the class where we actually start with C programming and do translations into assembly language like LC3 or, ARM64, whatever, and actually look at sort of what that C code turns into for assembly. I don't know broadly, generally, if that's going to be like the big thing, the big thing that's going to make everything better. Similarly, I've debated, doing Raspberry Pi. We've talked about, which is cool in the sense of, it looks cool on a resume, and for those of you that are into the embedded space, that's a kind of a cool thing to be able to, write code for a real processor and run it on a real processor. The problem is that if you're struggling with LC3, I think the struggle would be more if you were actually just doing this for an ARM64 processor, which is, I don't even know, way more complex. Okay, I was going to say 20 times more complex, as a package, and I'd have to find the path through it. You know what I mean? Find the little parts that are going to be meaningful to you, and I haven't done that yet, but I hope to and intend to. Anyway, that's the quandary. We've talked about that before. So, yeah, but okay. But so Jay, hit me up, right? Let's get some other time where we can talk. And let me see, Eisen, I think we handled your question stuff. Caleb, same thing. You know what I mean? Where the trickiness is. And let's talk about whether we want to try to do like a later in the evening help section sometime about
Dr. K,
the
how do I
LC3.
be less dumb?
What's that, Chris?
How do I be less dumb?
Man, I can't help you with that.
Because I went and I did the exam, and I'm not going to cheat or offer any answers, but you know how they have a 2-hour time limit? It took me an hour and 40 minutes to finish that exam. I'm really dumb, dude.
No, you're not dumb. Yeah, that's right. Thank you, Morgan. Yeah. See, I'm not gonna go. Oh man, who's our Ramsey? Chef Ramsey, right? I'm not gonna go Chef Ramsey on you. No, look. Here's the thing. This is my words. By the way, the 2-hour limit is just kind of an arbitrary. It's not. If you run out of time, you know what I mean. Then you just let us know. We can open it up again, let you go. I mean, it's not meant to be timed. You know what I mean? But it is the intention that if it's a little bit of a wake up, if you are taking 2 solids for some of these, then it probably means you're not quite good to go. But I've had a couple of students that got.
Because I'm dumb.
No, Chris, stop saying this about yourself. Stop it. No, the deal is that everybody has different aptitudes, and some stuff clicks real fast, other stuff, moves real slow, and everybody's different in terms of what it is that clicks. And right. So yeah, so Mike's saying no one should feel bad about not understanding this stuff. It's a different paradigm, right? Yeah, so that's right on. So I'm going to chastise you, Chris, for using the word dumb on yourself.
For being dumb.
For being dumb. I'm going to chastise you. No, don't say it. Don't say it. Because I just don't think the self-talk's helpful. That's all. You know what I mean? Because you talk yourself out of it, then every time your brain goes to try to embrace it, the other part of your brain just goes, Dad, don't bother embracing it because you're dumb. I think it's better to just kind of say, figure out the part you do know and get your head around that part, and feel good about it, feel confident about it. Then you build to the next part. Feel confident about that part. You know what I mean?
I think people also they tend to like focus on the like the
We shall
really
see.
big picture compared to like the small aspects of the LC3. Like if you focus on like add or the other, you know, inputs for the LC3, like I don't even know all this stuff as well, and I'm like kind of feeling overwhelmed with it. But I think that, you know, taking it small, like by small steps, I think that'll very much help. And you know, getting help from you and the TAs, that's definitely good for the people that are like way behind, including myself. So
Yeah.
yeah,
And even just a little behind, right? Or even just struggling
yeah,
with the
yeah.
moment. Well, I had another comment coming through. Who was that?
Oh,
Maybe not.
I think it was my echo or something like that. But no, that's what I'm saying. Yeah.
Yeah. No, Zach dropped in the me with calc sometimes. Yeah, right. And I know Zach's actually pretty good with the math thing. I remember taking 2 semesters of calc in college, and I think it was like sometime in my first month of second semester calc that suddenly I understood derivatives. It was like way late, you know.
Oh, really?
We're on integrals, right? And I'm like, wait a second. I'm like, you know, why didn't I know that last semester? You know, while I was rocking my B or whatever in calc. You know, I mean, it's just understand that this is why it's like that language fluency thing, right? And then let me give you one more. I know we're a little bit off topic, and that's okay. It's on topic really broadly, right? It's not on LC3. Hang on really quick. Okay. But this is the overarching. Sorry, Jay. That meme is just that GIF is just killing me. I'm gonna have to like scroll it up or down to get it off my screen.
Yeah.
The
She's actually really funny.
yeah. No, what I want to say is, so Dr. K's philosophy of learning. Have I shared this with you? Dr. K's philosophy of learning, and this is true of pretty much everything, but especially anything that requires fluency. But I think that's true of basically almost everything. But when you look at like musical instruments or languages or, you know, any of these sorts of things, right, which involve, you know, notational systems and things like that, my core philosophy of learning is really just a couple steps. Number one is to enjoy doing it badly, which seems a little weird and counterintuitive, okay? But enjoy doing it badly just means you don't beat yourself up. You like I remember watching some of my kids, like when we got our grand piano, right? Really nice Yamaha grand piano. And there were some of the kids at the time that the instrument itself was so tactily, you know, from just a tactile perspective, it felt so cool. They would just like need to touch it. And they became sort of really half decent, you know, pianists or piano players because they were drawn to the instrument, right? And I felt the same way about guitar and bass and things, you know, like just the instrument itself was so cool. I needed to just kind of keep my hands on it, even though I couldn't do anything with it, right? That's emotional, and that has to do with sort of persuading yourself. That's why, Chris, I'm going, don't play the dumb card because, hey, look, everybody is dumb about everything the first time they touch it. Now, the threshold to get to, you know, less dumb is steeper or flatter, you know, depending upon individual aptitude, right? But I'm just saying, if you can just get your head around, like, okay, no, see the coolness in it, see the value in it, and somehow get your head around enjoying and talking yourself into the value of the moment, of the experience. So that's step number one, just enjoy doing it badly. And the second one is trust your brain. Literally, that's my entire philosophy of learning. Because when you enjoy doing it badly, you stay in it. You stay with it. If you put it down and go away, you're not doing it at all. So you're not doing it good or bad. But everybody first time does it badly. Everybody. I'm a pretty decent guitarist, as Zach can testify. But the truth is, you know, I remember the very first time I ever tried to like make a chord. I was 18. The first time I ever attempted to make a chord on a guitar, and it was spaz central, man. It was such a spaz. It was a D. This is not a complex chord, you know. And not only that, it hurt my fingers, right? And but it was just so cool to do that I just spent some time. And then eventually you get like the one thing. But so in other words, you trust your brain. That just means don't put a lot of pressure on yourself. Don't talk yourself down. You just do it a little bit. Like last night, I'm playing my drums. I play drum kit. I've played drum kit for about a year is all. And because I wanted to so desperately, and I finally got my hands on a really good acoustic kit. I just noticed last night I was doing things I had never done before, that I'd never tried to do before, that I was suddenly just doing certain things. Why? How? Because my brain wants to solve the puzzle. Your brain wants to figure it out. It does. If you stay in it, your brain just starts to go, that's why you get all jiggy about, puzzles, because your brain wants to solve the problem. It's why you get jiggy about comedy. Right? In all of comedy, the reason the punchline makes you laugh is because you had to solve a puzzle. Do you get that? Your brain, it's related to the principle of Gestalt in psychology, but your brain wants to bring this wholeness to the thing. So the reason that you laugh is that when a comedian says something, they always have to leave a puzzle for you to solve, right? If they don't, there's no gap to bridge, and it's not funny. If it's too obtuse, too weird, you're like, I don't even know what you're talking about, right? And it's not funny. But if there's a little bit of a puzzle for you to solve, right, then you solve that puzzle. And when it's really done well, when it's really, really done well, it gets you so, it juices your brain chemicals so much that the pleasure centers of your brain just flood your system with a bunch of chemicals, dopamine, serotonin, a bunch of things, and you start to laugh, which is actually kind of a chemical response, right, in your body. But you're laughing because you yourself solved a puzzle. So your brain really, really wants to do that stuff. Your brain digs that, solving the puzzle. So with any kind of learning, and yeah, Zach, it was the summer of 69. Played until my fingers bled. I've never played until my fingers bled, by the way. I have played until they were black and blue and bruised and so painful that, whatever. But, never played till they bled. To me, you're doing something wrong. I have, however, I remember one time just jamming with my band. I was playing the bass, and something happened, and I don't even know how I did it, but I managed to cut myself somewhere on my bass, and my hand was actually bleeding. I mean, it was my right hand, and there was like blood running down onto the strings, and that was actually freaking cool. I just want to say, when you're jamming with your band,
Metal AF.
Right? And you're jamming it. There's blood running off your hand onto the strings. And you're like, no, man, I'm playing through this. It's for the music. It's for the art. I'm doing this for my art. Anyway, that was pretty cool. But it wasn't because of, fingertips bleeding. Exactly, man. That's right. So, okay. Anyway, you see what I mean? And this is why you've got to budget time. You've got to budget time every day. Block that time. Do the thing. Find a way. Find a reason. Find a motivation to stay with it. But you've got to do it every day. You can't just go, I've got time. I'll put it down for a month. You're screwed. If you do that, you're seriously just screwed if you put it down for a month and try to come back. Because too much is going down, and I know for some of you it's like, that's a little late, because some of you are like, shoot, that's what I've been doing. Yeah, so still possible, but decreasingly possible to pull it out. You know what I mean? To pull the rabbit out of the hat by this point. Okay, I hope that helps a little bit. Okay, Chris, no more dumb language. Okay, no more dumb.
I'll see what I could do.
Yeah.
Teach me about assembly.
Just say, I love this stuff. I love it. I want to do this stuff. I want to be an assembly god. I want to be like Dr. K. I want to be like on the keyboard and blood's just coming off my hands and it's all over the keyboard and I'm just going, man, for the love of the game.
But I'm going to short circuit my keyboard.
Nah, yeah, that's right. Well, you got to go, don't go heavy blood flow.
Okay. Teach me about assembly.
I'm just saying, yeah, let's talk about assembly. Should we talk about the assembly process? Let's do it. Okay, here we go. We, by the way, talked about, let me see, let me get to the right spot. Yeah, we talked about this idea, right, of an instruction. And this becomes crazy important. The optional label, which does, it can be there or not. The instruction, which is the opcode, sorry for the off angle. The operands, which is not just -1, but all of these are the operands, right? And an optional label, if you recall. These are required, the others are not. Okay, we also talked about, just by way of review, the pseudo-ops, also known as assembler directives. I'm not going to re-teach it, I just want to touch it to remind you. And these are instructions to the assembler about how to do its job. These are not machine instructions, okay? These are not instructions or operations that turn into machine code, okay? .org says where to put it in memory. .n says I'm done. .block word tells the assembler to allocate this many words of storage. .fill says to allocate one word and to put that value in it. Now that one does look a little bit like it shows up in your program, but you understand it's still an instruction to the assembler to grab a word and to put a value in it. That's still instructions to the assembler. And then .string z, where you can put an n character string that has to be null terminated, meaning that the last character in the string is a 0. Okay. And then we talked about trap codes, which are system level instructions. And these system level instructions are in fact instructions in the program, and they come out being trap, which is instruction 1111, that's the opcode, and followed by this vector, what we call a trap vector, which is the number. We'll get into that, and I'll show you where those are actually in memory on the LC3. You can go look it up yourself as well, but I'll show you. We'll walk through it, okay? The assembly process, here's what we're going to do. There are in the LC3 at present, until Zach and I modify it, which I think we're going to do. We really, really do need to do that, Zach. Maybe Thanksgiving. There are 2 passes. So in other words, here comes your code, right? And it starts at the beginning of your code, and it goes until it gets to the .end. The assembler does. It just reads your file. Then it's going to do that again. It has to do that twice, and I'll explain why. Okay, but it's called a 2-pass assembler. You could do it in 3 passes. You could do it in 4. But you have to kind of pass through it. And the first pass is we build a symbol table. And all that really means is I make a pass through looking at all the labels. When I'm in machine language, there are no labels, so there is no symbol table, right? I hope that makes sense. So when I'm doing it in assembly, I have labels, right? Like loop and, whatever, referencing memory locations, I, J, K for little, whatever, looping variables. I've got these labels. So I've got to take all the labels and know what it is they refer to in terms of memory locations. That's all the symbol table is. The second pass is where I walk through each instruction and actually translate it into machine language. And you will remember, you must remember, that there is a direct one-to-one correlation between an assembly language instruction and the machine language that it represents. And you can look at machine language and you can tell me what the assembly would be, right? What the high-level instructions are. Or you can look at the assembly language and you can tell me what the machine language would be. They're just directly correlated. The only difference would be that the assembly language has symbolic names that you have to convert. Right?
So assembly is kind of just like a shorthand for writing machine code.
Exactly. That's all it is. That is literally all it is. And when you get to higher level languages, in a sense, it's also a shortcut. Only a high level language, instruction is going to yield a bunch of assembly language to do what it's trying to do the same thing. So in fact, a lot of compilers start with your high level programming language and converts that into assembly, then assembles that into machine language. That's not uncommon. It doesn't have to put it into assembly language. You know what I mean? But that does happen. Okay. You can also, because of .orig and .end, you can separately assemble chunks of code. So I could do a little bit of code, process it, it'll load that into memory. Then I can load some new code. And by the way, Zach, this is what we talked about a little bit, but what I want to do is I want to have a file where in the same file it goes .orig, blah, 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 .end, and then .orig and have it all in one file. So I can have one big file that'll just, reset and put it into the next spot. There's no reason that's got to be an easy fix to the simulator. Says I. But you can separately assemble different chunks and then put them, into different spots in memory. All right. The other thing that the assembler does is it finds errors. If you in machine language, right, you're dealing in ones and zeros, and everything you can possibly do there is going to be an instruction that the machine will try to run. There's no error detection when you're programming in machine language, machine code. With assembly, there can be. Okay? Like I can reference a link, like I can do like a branch to some looping variable. But remember the branch instruction has like some PC offset. I don't remember what it is. 9, 8, something, right? Whatever that is though, if I have a label and the label's way the hay over there and it's outside the PC offset, the assembler will complain at you and go like, yeah, that you can't actually, it's too far away. So the assembly will, and if you give it like an instruction that's not a real instruction, you instead of and you type Andy, the assembler is going to complain at you. So any of those kinds of mistakes, syntax mistakes, either syntax mistakes or in some cases, kind of logical mistakes like you can't get to. If the assembler only complains if it can't make a machine instruction out of what you said. Where you say Andy, he's like, I don't have an opcode for Andy. Stop it. Or you give me a number that doesn't actually fit, in an immediate 5, and you give me a value that's like bigger than, you give me a value like 700. I can't put a 700 in an immediate 5, and the assembler will complain at you. Okay. So here's what we're going to do. You ready? Of course you are. If you're not, don't know what to say. We are going to take this code right here. It's not really complex. There's the .orig. There's the .end. And we're just going to walk it on through and play assembler. We're just going to do what the assembler would do. Okay? This code just counts down from 10. That's it. Let's look through so we understand what it's doing. I have this variable called 10, which we already had this conversation, right? I ought to say something like count or I or something. But anyway, it's 10. And this is the value 10, decimal 10, hex A, and a dot fill. So this just puts the value 10 right here, right? I load that from that value into R1. Now R1 has the value 10. And I'm just going to decrement R1 and put it back into R1. And as long as I'm positive, I branch back to loop. I go boink, boink, boink. I go 10 times. And then finally, it's going to be 0, right? And every time I do this add instruction, because I'm writing to this register, it is setting the control codes, NZP bits. It's setting those. and it's going to be P bit set, P, 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 P. And then it's going to be finally go to Z, which is 0. And when it does that, I don't take the branch. Instead, I just fall straight through and I halt. This is a boring, dumb program that doesn't do anything, right? This program doesn't, you could put the stuff you wanted to do like inside the loop. You know what I mean? Like inside above this BRP. You could put like all, the things you wanted to do 10 times. But this is just the structure. Okay, cool. So the very first pass, all we're doing is we're building the symbol table, and this is essentially what the symbol table looks like. Conceptually, it's in code, but, So there's going to be a symbol that's going to go here, and there's going to be an address that goes here. And then we have this thing, it's like a program counter, but it's called a location counter, abbreviated LC. The program counter is the address while the machine is actually running, right? Then the program counter is incremented and moves around. The location counter, it tracks basically what the program counter would be at that point. Does that make sense? So it's not the program counter, because I don't want you to get confused with the idea that the program counter is a register while everything's running. The location counter is our own little looking at it going, here's what the program counter would be at this point, just so we can keep track. Okay? So in this pass, what we're going to do is we're going to read each one of these things. So we read that. It's a comma. It's a comment. It's a semicolon. So we ignore nothing. It means nothing. Okay? Then we go .orig 3001. We put 3001 here in the location counter. All right? Now we look at this load instruction. This load instruction is going to be at location 3001. There's no label on this line, so we ignore it. Okay? That's a comment. That's a comment. Now we get a label called loop. Okay? Now notice, let me back up. Notice that right here we had this instruction, which we know that instruction is going to go to 3001, but we don't care, right? We don't need to do anything about that right now. Then as soon as I move off of it, I increment the location counter. Now 3002, but the comment is not a spot in memory. Next comment, not a spot in memory, but loop is. So what we do is we basically just say, what's the symbol? Loop. Literally, that's just a string. What's the address? Whatever the location counter says at that time. That's it. That's all we're doing. Okay? I increment the location counter as I move off to the next instruction. No label, no label. Okay, notice that when I was here, it was 02. Now that's 03. That's 04. Comment doesn't do anything, but I moved it to 05. And when I got to 10, the label 10 means essentially location 05. All right? And I'm done, and I get to the end, and I stop. All I did was built a symbol table. How many symbols are there? Right here. 2. How many entries in the symbol table? I don't want to offend the British. I'm sorry. 2. Is that still a thing in Britain?
No, it's not.
Okay, that's an ancient thing? Because there's that famous picture
No,
of
that's very much still alive.
Is that
when
still
I was
alive?
in the MPC
Okay.
in England, they made sure to tell us, don't do that.
Okay, it's inadvertent, and I apologize to the British. There's that famous picture of Winston Churchill doing this, to the press. Anyway, all right. So yeah, I apologize. I mean, this is not uncommon in America. You know what I mean? Where it fits better with your joints. It doesn't mean anything. Okay. I have a symbol table. All I did was said, whenever I say loop, I mean 3002. Whenever I say 10, I mean 3005. That's it. Then I'm going to convert this thing to machine code, but I now know what the symbols mean. So I go, right? And now I'm consuming it like, okay, comment, I don't care. Comments, I'm getting rid of, and I reset the location counter again. Okay? And 3001, and then I do this load, but now see what I'm doing? It's like, oh, load from 10. 10, what is 10? I look in the symbol table. 10 means 3005. Okay? Now this is also the part where you got to go look at the load instruction. And I want to do this real quick. I don't have this right here because I'm a doofus. And by the way, that's different, Chris, than calling myself dumb, because I know I'm actually not really a doofus, but... And sometimes I do call myself dumb. Let's be honest about that. But I know that I'm not dumb. Okay, load. There's the load instruction. The load instruction needs to have, right, these 4 bits for the opcode, the destination register, and then the PC offset 9. PC offset 9. Well, the value I have is 3005, right? Anybody see the conflict, right? Oh yeah, thank you for Mr. Bean, Morgan. That's just equal opportunity. Wait, is he doing the 2 fingers? Yeah, he is. Mr. Bean doing the British flip off.
No, he's doing the
Is
one
he doing
finger.
one? Is he doing a flying the bird?
Okay. Yeah, that's from a skit.
Nice. And by the way, this is obscene in Italy. It's also like rock and roll and hook 'em horns if you're at UT Austin. It's also obscene in Italy. FYI. But I think that I think they understand if they're watching Texas football over there in Italy that when the whole crowd is going that they don't mean it. Okay. So what do I got to do? Well, I'm talking about 3005. I'm at location 3001, and the way I got to do this is with a PC offset 9. So what I do now is I have to run a little bit of math, okay? 3005 is this spot right here. The location counter is 3001, which is this spot. And you know that the program counter, when it's really running, the program counter will have been incremented. So this is 3001 plus 1 is what the program counter would have been. Wait, hang on a second. What are we doing here, Mike? Was that, Zach dropped that one. No, Mike. Oh, that's the, I think are we insulting Texas now? Is that what LSU's doing? Yes, we are insulting Texas. Okay. Hand gestures, right? Okay, so this is what the program counter is going to be. And so the program counter is going to be 3002. Well, what's the offset going to be to get to 3005? And the answer is 3. You can look at simplistically as, 3005 minus what the program counter is going to be. Or you can just go, look, we're here. Program counter will be here. Okay, 1, 2, 3. So the offset is going to be 3. Okay, that is the PC offset 9. Okay, and that's R1. And then we just do the next step as well. Let me back that up. The load instruction is 0010. R1, that's right there, 001. And then here's the remaining 9 bits for the PC offset 9 for that guy. Boom. I just assembled from this instruction from this assembly instruction to this machine instruction. Right there. That's the step. Okay? You know you love it. Okay, then we comment, don't care. This line, we don't care. Notice that we're not doing anything with the labels now. We know what the labels are. Okay, now I'm going to add R1 to -1 and store the result into R1. So let's go back. Let's look at add. What do we got? This is going to be an immediate value. So you know it's going to be this one. We know what the opcode is. Destination, source. That bit's got to be 1, and we need an immediate value. So right here, let's do it. It's an immediate. You see how we do that? So the add goes 0001. Register 1 is 001. The next register 1 is 001. The 1 bit we set because it's going to be an immediate value, and -1 is 11111111111. All ones. Okay? Boom. We just assembled that line. Now we're going to branch on positive to loop. And let's look at it again. There's branch. So we know that we got to have 0 for the opcode, 0000. NZP, we're going to turn this bit on because that's the one we care about. And then it's going to be a PC offset 9. So once again, we've got, well, the loop, we know that we're at location, the program counter is going to be at this point 3004 at the time the code's running. Right now it's the location counter plus 1. 3002 minus that, right, because that's our target. What are we really doing? You know, we're going to be here, program counter will be here, and we'll go -1, -2. So we know this has to be -2. Well, 3002 minus 3004, boom, -2, and that's -2. Which you can probably do kind of intuitively. If you add 1 to it, you get FFFF, which you already know is -1. All right? And from this point, boom. Again, the branch is all zeros. The P bit is 001. That's saying we care about the P bit on those NZP registers. And then that other value is the PC offset. And then this one is just a straight translation. Halt is trap 25. That's the trap instruction. That's just reserved. We don't touch it. And that is hex 25. Okay? When I say trap 25, I do mean trap hex 25. All right, keep going. This dot fill. Now notice that at this point, when we were here, it was 04. As soon as I did that one, I incremented the location counter. So this is now the spot in memory where this dot fill is going to happen. And so it looks at it and goes, oh, you want a 10 there? Great. 0, 0, 0, there's A. And that's what's at that location. And then when it goes to end, it's done. That is our executable machine code. Everybody cool? Anybody freaking out? And by the way, we are almost done. And this will be the end of Module 8. Zach, we're going to be Module 8 deadlining now. Okay, anybody struggling at all? Well, depends on the threshold, right? Sometimes you just need to, go back and rewatch it on YouTube and roll through the homework and.
So deadline on the 24th.
That would be correct. Is that the Tuesday of Thanksgiving? Wait, is next week Thanksgiving?
Yeah, I don't know.
Woo!
Putting a deadline in the middle of the break.
It doesn't matter, right? It's just that's all.
We'll
fine.
just make the deadline this Friday.
Yeah, that's the alternative. No, make the deadline Tuesday because that's when it's officially. Look, you're supposed to keep up. You know what I mean? You're supposed to keep up. Do it. Yeah.
Such
Okay.
a sweetheart.
Okay, that's how we do it. You walk through that process and then use the LC3 simulator. Right? Thank you, Mike. Just start trying stuff in the simulator, guys. Correct? Right? Walk through each instruction, see what it does. That's what you got to do. That is the easiest, best way to do it. Okay? So yeah, thank you, Mike. That really, truly, it's just exposure. You've just gotta spend some time with it. Okay, I'm moving on. And there's really only one more thing I want to say in this lecture, and there's like one more slide, okay? This seems so radical. What time is it? wicked radical. We're jumping into chapter 8. Okay. All this slide is trying to say to you right here is that you can have, do I even have an extra one? No, that's it. Is that you can assemble multiple object files. We call them object files or object code. You can assemble multiple object code or multiple segments and separately load them into memory and then just, jump over there, jump wherever the stuff is. And it turns out this is just introduction to an idea that what an assembler creates is object code. Okay? And that there's this thing called a linker that takes the object code and actually builds it all together. Then later on, there's a thing called a loader, which actually puts it into memory. With the LC3, we're skipping all of those steps. And you literally, by saying .orig, you literally decide where that's going to go. I mean, you're just like, oh, put that in location 3010. And the assembler goes, sir, yes, sir. And just puts it right there. That's it. That's it. That's all that slide's trying to say. Just know first exposure to the idea of you can compile separate modules, link them into one program, like a .exe in the Windows DOS world, but some executable file. And then when you actually like double click it or say or type its name or whatever, then the operating system will give it to a loader, and the loader actually goes out into memory and interfaces with the operating system and goes, hey, where can I put this? Where do you want? I want to load this, and set some things up so that it can run okay. Okay, we are way, way, way simplified here in LC3 land. Okay. Da, 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 da. Isn't that fantastic when we finish a lecture? You're like, no! I'm still on 5. Yeah, sorry. Got to keep going, man. We got to keep moving. Okay, we are on chapter 8, though. I told you let me say it one more time for the record. There's still going to be some people that are going to be like, wah, 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 it all went extra fast at the end. No, it did not go extra fast at the end. The pace remained the same. The granularity of the modules got smaller, but the actual concepts that you were acquiring, and the pace at which the new material is coming remains the same. Okay? Okay. Thank you, Zach. Zach. Nobody is going to break my stride. Let me see something.
I just know how much you love it, so.
I do. Let me see something, though. As we make our transition, what's the deal here? Yeah, here we go. Yeah, we're going to just... Oh, that's really creepy because the GIF is actually right in beat. Close. The first measure, the GIF was right on the money. I hate this song, by the way. Can I just say that?
Why do you have to sing
I have certain abilities that can.
Okay, I'm going to tell you what.
Play the song.
No, you know why? It's because...
We should all unmute our mics and sing this song to get more like
What's that?
I said we should all unmute our mics and start singing way even more.
No, the reason is because Santa has infinite patience. This is why it's a test.
Oh my god.
This is shocking, is it not? You should listen to the crap that the elves do. It's absurd. So this just is kind of training for me. All right, let's get rid of this crap. Zach. Okay, yeah, enough of that. Break my strip. Matthew Wilder. This, by the way, the same decade that brought us Oingo Boingo brought us this crap. I can't explain it. I don't know what to say. Okay, so yeah. Oh, ain't nobody gonna break my stride. Now, I just realized there's a, dang it, I'm not sure the best way to do this. Because I don't have my Windows machine, I have a couple of AV things that I wanted to do here. And I'm not sure. I'll find a way. Actually.
AV things meaning audio.
Yeah,
things
it's more the
like
audio
that.
than the video. Yeah. I've got like cheapo ways I can do this, like get it on my phone, for example. You know, actually, what's the best way? I didn't realize we were going to be in chapter 8 today, or I probably would have prepped something. Or I might have realized it and still not prepped anything. Best way. What's the best way? Okay, hold on really quick. Because there are just a couple things that are really, really worth it. Okay, no, I got it. I know what to do. Okay, hold tight. What I really need is a Windows machine for broadcast. That's what I really, really need. Then Discord wouldn't have the dumb problem where you can't broadcast the sound. If on Discord for Mac, I can't get the sound broadcast. I mean, it's like a weakness in Discord. I love Discord, by the way, but that's just one bug, feature, whatever you want to call it, that's not in place. I will have this momentarily. Just watch my stride. Don't do it, Zach. Seriously, just don't. Just put down the keyboard and back away slowly. We're almost there. Oh, yeah. Okay, let me see. I got that guy. No, come on. Okay, no, I thought I was good to go, but is it no good? Okay, I'll come back to that. Because we won't finish the whole thing anyway. I'll have that ready for Thursday. All right. Okay, we'll just go without. By the way, I just want to say, you remember on the first day when I told you that I was rolling the beard for being an extra and that I wanted to know if I should go full Santa mode, and you all said I should go full Santa mode. There was a universal, you cried out with one voice,
Yes.
full Santa mode. And now here I am, done with The Chosen. They're done filming. I have a film thing I'm now doing, which I'll tell you more about later. I have these cosmetic Santa glasses, and I just made a post yesterday to Facebook just talking about my time on The Chosen, and got a request from an artist friend of mine if I'd be willing to do basically a headshot shoot for her to do Santa artwork, basically modeling Santa, because I got to shave it. It's got to go. Before Christmas.
You're just so handsome.
Oh, thank you.
You're a model.
I am a model. That's right. This is not the kind of modeling, right, that everybody aspires to. Oh dear, dear me. No, you guys, seriously, you need to back away from the edge. Morgan, you need to back away. Yeah, sorry I brought it up. I am so sorry that I brought it. Thank you. Yes, Michael, that is how I feel right now. Okay, let's do this. Let's do it. We're talking about input and output. Here's the thing. Okay, this is very important. What I'm about to say is far more important than these absurd gifts that you are dropping in. Okay, listen very carefully. Pretty much everything we are doing after this, from now till the end, is little add-ons. It's just a little touch. All of the major concepts that are sort of inherent in understanding and doing assembly language programming are done. Okay, you got to refine it. You got to get fluent, et cetera. But there's a few touches, and so I/O is one of those, and there's a few other things, traps and interrupts, but these are really, in my view, these are much smaller concepts. Okay, easier concepts to get your head around than this whole foundation of assembly language and machine language and all this crap we've been dealing with so far. Okay, so let's go I/O. We got about 15-ish minutes to go, and I say we do it. Now, here's the big obvious thing, right? Once you've got this ability to program your computer, you got to be able to get stuff in and out of it, right? That's the big duh. That is the big duh. And in real computers, you've got all kinds of stuff, right? You think about it. You've got your monitor, you've got your laptop monitor built in, you've got a desktop monitor if you have a desktop. You've got keyboards. In fact, I've got a Bluetooth keyboard and a regular keyboard on my laptop, and they both, can send stuff. I've got, what else? You got the speakers, right? You got a pluggable aux jack in this thing. You got some USB-C adapters, which is moving a bunch of stuff in and out. But you know what I mean? You've got gaming adapters, right? There's just every imaginable thing. You've got Wi-Fi, you've got networking, right? You've got Ethernet, Wi-Fi, Bluetooth. Not uncommon to have all three of those. You could have, there's a hard disk, for example. There's always some kind of hard drive. Whether it's moving, spinning platters or solid state, either way, you've got all these things that have to come in and have to go out of your device, of your phone, of your laptop, of your desktop, whatever, any computer, right? The touch surface on a smartphone, right, is an I/O device. Et cetera, et cetera. The camera. There's a bazillion. There's a big variety just categorically. There's probably dozens, and then there's thousands and thousands and thousands of individual devices, right, within these different categories. And you've got to be able to talk with these. The computer's got to be able to have a way to get stuff in and out. Okay. And so. So that's the bottom line. The LC3, again, very simplified, only has a keyboard and a monitor. That's all you have to worry about. And it's the simplest form of input is the keyboard. Kind of the only true essential input really is the keyboard. And you could say that the only true essential output is the monitor. Or you could say that you could get by with like flashing lights and switches with like the original the Altair computer, which had literally switches for input. You were inputting individual bits and then flashing lights for output. So anyway, once again, the LC3 is so simple. and it just saves you a lot of crap, a lot of having to understand all the other stuff that might be happening. So here's the basics, okay? These are also fairly generic. By which I mean these are ideas that are going to recur over and over and over and over again. Okay, you're going to go to other devices and they're going to do it kind of like this. They will all be. This is the weird thing about assembly and hardware. The concepts will recur. The specifics will like never be the same twice, right? So, my first assembly programming was on this simulator in it was a prime computer, and it was this octal based base 8 hardware simulator. I've done them with accessing via Hollow Earth punch cards, done it with my first professional stuff was x86 assembler. And I did stuff at Novell. We were down in the kernel level debugger where again, it's kind of x86, but it was more 486 or Pentium, back then, which is the hot ticket. And then I've been inside of, assembly language for like 68,000 processors from Motorola, the Dragon Ball processor, just a lot of different things. And then we're at the LC3 now. And I'm just trying to say I've had my hands on maybe not a dozen, but maybe a dozen, different hardware architectures, that I've had to do something with. I was doing some kind of engineering thing or consulting thing, where I had to get inside, the hardware a little bit more and inside the assembly. And all of that to say, it's never been the same twice, ever, and it never does, okay? There's always little variance in the machine instructions, in the assembly language, in the architecture, in the what we call the instruction set architecture, the ISA, the registers, the memory map, the memory model. It's always some difference, and therefore you've got to have the documentation to do that. Okay, so but what we're talking about are principles that are pretty standard, that the concept exists even though the particulars are going to be different. So to talk to an I/O device, to or from an I/O device, typically you have two registers. And now, we've talked about, what are the registers we've already talked about, right? We've got the eight general purpose registers, right? 0 through 7. We'll learn later on, by the way, that, register 0 does have a sort of a default usage. Register 7 has a default usage. When you make a jump call, a jump to a subroutine, which we really haven't talked about, register 7 gets the program counter to tag along with you. And when you do reading and writing to characters from the keyboard or to the monitor, register 0 is the carrier. These are built into the LC3. In other architectures, there might be a specific sort of keyboard register, or a keyboard character register, or an input register, or an input queue that's just built in and you can get to it. And I just pull it off the queue and get the next one and pull it off the queue. So different architectures but often there's some things built in. Okay, but commonly, there's something built in. But just think about those registers. What are the other registers? Program counter is a dedicated register. Instruction register actually says register. Module, what's the question, Jay? This is module 9. Wait. Which one is it? Zach? Hang on a second. Which the module where we don't even have any lectures for it? Is that module 9 or 10?
Pretty sure it's module 9 because the homework is like, turn in your notes and stuff.
Oh, we're jumping.
Yeah,
okay, here's what I think we should do then. Sorry, man, my bad. So we're actually on the module 10 lecture. But I think what we should do is on Thursday, because we usually spend about a day And then we can do some other help sections. Where Module 9 is the only thing you do for Module 9 is you do the homework. Thank you, Jay, for catching that. Is we submit, notes for your own notes for building the larger program.
There's no exam either.
That's right. There's no module exam for Module 9. When you've turned in those notes and you've taken the module exam for 8 and 10, you just get the module credit for as if you had taken the Module 9 exam and gotten 100% on it. So what I'd like to do is just spend a few more minutes, working into Module 10 a little bit. Then on Thursday, we'll do the Module 9 where I'm going to just talk about ways to approach that larger project and talk a little more about the design of that. Cool? Yes, I assert. Cool. Okay. So every I/O device, it's common to have some kind of dedicated registers. Oh, I was kind of going program counter, instruction register, right? Those are dedicated registers. The 8 general purpose registers. What about the 3 control codes, N, Z, and P bits? Each of those is a dedicated register. They're 1 bit, but they are a dedicated register. What you're doing here is basically having a similar kind of a thing. Oh, what else? What are some other ones? How about the MAR and the MDR? Those are dedicated registers, right? The memory address register, the memory data register. So cache, Mike, I'm correcting your spelling on that. By the way, that actually comes from wrong cache, Mike. That CACHE, it's actually French. If any of you speak French, but it's sort of the verb is cacher, to hide. Something is to cacher, and so therefore a cache is it's like a hiding place. So it's sort of like a little stash, which I don't know if that's spelled with a CH. But anyway, what you do, right, like geocaching, exactly. It's like that the CACHE, it's like a little hiding spot, something to be discovered. So cache memory is memory that's like close by really fast, and I can just kind of like keep stuff hanging out there. So I don't have to go all the way out to memory every time. I don't have to go onto the bus, MAR, MDR, and all that madness. I just keep it close by, and I've got this like local memory on my CPU. That's cache memory. Okay. So CACHE. But these I/O devices have a data register and a status register. And the idea basically is that the status register just says, you got something for me or not? Status register goes, yep, here's a character. I got a character for you. And then you can go, thank you. And then you go look in the data register and you pull that character out. As soon as you pull the character out, the status register resets until it gets a new character. That's coming in. On the way out, it's the same way. You're like, hey, monitor, can you accept a new character? And the status register goes, yeah, I'm good. And then you put the new character that you want to give to the monitor into the data register. And then it just gets consumed because magic. We don't care right now. It's magic. I'll show you later, but it's actually magic for now. That's it. Really, that's it. And so you understand that this is always at play. If I'm doing Wi-Fi, right, and I'm going to try to send something, I've got to know that the Wi-Fi adapter can take the data I want to give it. Okay, now I give it to you. There's got to be some way to read the status. Then there's got to be some way to give the data. They're separate functions, right? And we do the same thing in our own communication. You know what I mean? If you're talking to somebody, you're like, hey, can I talk to you for a second? What am I doing? I'm checking the status register. And you go, yeah, sure. That's coming back on the status register. Then I start telling you what it is I want to tell you, and we interact. But on literally every communication interaction we have, there is some sort of human variety of a status register to say, to be able to ask, are you ready to receive what I'm going to give to you? Or do you have what it is I've come to get from you? Right? That's what the status register just tells me if you're ready or not. Then the data register has the actual thing. And you might not think about it, but just go to the store, back when that used to be a thing, just all the interactions we have with people include these little cues, but they're really status register and data register, okay? All the time. And if somebody doesn't check the status register, and they just kind of like little kids will do this to you, right? You're in the middle of a conversation and the kid will walk up and just start going blah, 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 right? They haven't learned about the status register, how to check to see, hey, can I I'm sorry, really sorry. Can I interrupt for a second? So yeah, that's the data register and the status register. And then let me see. Yeah. What else? And then I just want to say this, and we'll come back to this slide and keep going, and which will be after Thanksgiving. Actually, and the great thing about talking about the program on Thursday is that for those of you that are going to try to work on that during Thanksgiving break, that'll be good. So that'll be timing-wise really good. And we're out of time. I want to just wrap this up. We just think of like send a thing. I'm just going to send the thing, send the package, send the letter, whatever. The truth is that there's a whole bunch of stuff that actually happens. A lot of individual steps, right? On the output, even when you start sending, you have to know when it's done. And the truth is, even sending is like if I'm on the LC3 and I'm sending characters to the monitor, I literally send a character at a time. So I'm like, are you ready to accept a character? Yes, you are. Okay, here it is. Now, are you ready to accept the next character? Yes, I am. Here it is. That back and forth is happening constantly. And then when I'm typing on the keyboard, right, I've got to read. Somebody's got to read from the keyboard buffer. So he's got to go, I'd like to read the keyboard now. Do you have a character for me? No. How about now? No. How about now? Yes. Great. I'll take it. I do what I'm going to do with it. Do you have another character for me now? Yes, I'll take it. And that back and forth again, every time, all the time. So we think of it as like I type a thing from the keyboard and it all comes in. It might be 20, 30 individual steps with multiple assembly instructions for each step. Okay. All right. I think we should probably stop here and stop now. And let's see. I've got a tune to take us out that is way better than this crap we've been doing. And I want to stop basically right here.
I said
right now.
To China in a little
No,
no.
I got you way better.
You had to get your laundry clean.
What
right
does
here.
that mean?
Yeah, okay, I'm out.